All right, so welcome back to F110 Autonomous Racing. I hope everybody is doing well. Today, instead of a long format lecture, I'm planning to just introduce to you how to get access to the ROS F110 Autonomous Racing Simulator that we are now also hosting in a cloud server. So you already had an option to download the simulator as a standalone application, but as you know, moving forth till the end of the semester, we will not be using the F110 hardware and instead switching to the ROS F110 simulator. So I prepared this relatively short video compared to our usual, 1 hour 15-minute lecture. I'm going to talk you and walk you through and show a demo of how to access the online simulator. So why don't we get started with that? So just as a reminder, there are two ways to get access to our simulator. The easiest way, I would say, is to have a standalone installation, meaning that you just install the simulator locally as you would any other application or software. This simulator is open source and available for free on F1tenth.dev, which is the development webpage of F1tenth community. And on that website, you will also find tons of tutorials, including detailed instructions for how to go through the installation step by step. I think the recommended configuration for the machine is to have Ubuntu 18.04 with the ROS Melodic and Gazebo 9. That's what the simulator likes. But we have also gotten it to work on 1604 with ROS Kinetic and Gazebo 7. So you always have the option, if there's some trouble with the server or it's not fast enough, you can always just have a standalone installation. Another thing to keep in mind is that if you install the simulator inside of a virtual machine, then it may slow your virtual machine even down. So if you are considering a standalone installation, I highly recommend that you actually natively install it on your Linux machine and not inside a virtual machine. The second option, of course, is how to access this shared online version that we've created, and it's still relatively straightforward. You don't have to install too much stuff on your VM. It's just mostly configuration rather than the installation, and that's what this video lecture is going to be about, to give you an overview and detailed step-by-step instructions on how to install the online version of the simulator. All right, so this is just a screenshot of what you see if you visit f1tenth.dev. In fact, this is not what you see. You have to scroll down to get to this point. And so as you can see, there's a link to GitHub where all the installation and instructions are to install it. You can even watch this 30-minute excellent presentation by your TA when this simulator was presented at ROSCon last year in November. So as I said, the GitHub link will direct you to this wiki page where we have detailed installation and step-by-step instructions for how to install the simulator natively on your machine. And as you can see, glance at these instructions, it does require ROS Melodic, which is what I initially said. All right, so if you are doing your standalone installation and you run into any troubles, just post your questions on Piazza, and either myself or the TAs will reply to that as soon as possible. But the scope of today's video is to understand and get started with the ROS F110 online simulator. So there's going to be a bunch of critical steps which are listed in chronological order, which we need to follow in order to successfully set up our machine to be able to log in and access the online simulator. I'm going to go over each of these steps first and basically talk you through these steps first, and then I'm going to switch to my virtual machine on this laptop and actually show you how to connect to the simulator itself. So as you can see, there are 5 steps. We need to be able to connect to the University of Virginia's VPN first. This is sort of a non-negotiable step. You need to have your laptop configured to be able to appear on the UVA network or have access to the UVA network. So you have to go through your NetBatch ID verification and all that good stuff. But once you are on the UVA VPN, you configure your host machine or your ROS machine by making some very trivial changes to the bashrc file. Then I will walk you through the server side of it. So your machine behaves like the client and the simulator is hosted on the server. Every team has their own sort of workspace, right? So if you develop code for your virtual car, you need to be able to have access to your Catkin workspace. So every team has their own dedicated workspace. Teams don't have access to each other's workspace as well. I'll talk a little bit about that. And then finally, we have created a custom simulation tools package that you need to install also on your host or the virtual machine in order to actually see your car in RViz. And we'll see that when I switch to the live demo. And then we'll wrap up this video by a discussion of some best practices for teleoperation and to bring you to a point where you can visualize your car, you can control your car using the keyboard control teleop, just like you did with TurtleSim. All right, so let's get started with the list of steps first. And like I said, I'm going to just go through all the steps rather than switching back and forth between the presentation and the live demo. I'm just going to go through everything in the next few minutes, and then we will look at the live demo. So we begin by having the ability to connect to the UVA network. So this is a sort of the architecture of how everything is set up. So your machine is connected to the internet. You have a VM client or a dedicated Ubuntu machine. You do need a ROS installed Ubuntu machine, just like you would normally need to interact with the real F1 car in order to interact with the simulator as well. So you have the VM client, and you need to first connect to the University of Virginia's internal secured network through a UVA VPN application. I'm going to point you to resources that will help you to do that. And then it's on one of the computer science servers. In particular, the server is called GPU SRV05. As the name implies, this is a GPU-enabled server. That's why it's able to easily run graphics-heavy Gazebo and RViz installations for 8 teams at the same time. We have tested it for that. And this server is just like a very powerful Ubuntu 18.04 ROS Melodic Gazebo 9 machine. So once you are on the network is the only way you can have access to the server. And using the server, you can do 2 things. One is just to visualize what your car is doing. And you can see this is like the virtual track, and there's almost like a pit stop area for every car to spawn in this track. And this is the initial point from where you will begin your car every time you test your wall following or whatever algorithm. But this is only for visualization. In order to actually interact with your own car, there's a secure SSH instructions that I will share with every team. And using this secure SSH interface, you will be able to issue commands to move your car, whether that is through TeleOp or through your own custom ROS nodes. So here is the links to how do you get your remote machine on the UVA Anywhere virtual private network or VPN. And so you have instructions for your host OS, and based on that, I suggest you follow that, and it will take you through your official UVA Net Badge ID, which is required to authenticate. And there's a one-time process that you install some clients on your machine. After that, you simply choose that you want to connect to UVA, and it will authenticate at the backend and allow that connection through. So these instructions are at the URLs depicted here. One thing to note is that when you connect to the UVA network, your host machine or your virtual machine is going to be assigned an IP address. And this IP address will change based on what the virtual private network assigns your computer. Okay, so this might not be the same every time you are trying to log into the VPN using the same hardware. Usually it doesn't change, but it might change. So we just want to emphasize that this IPv4 address, which is assigned to your remote machine, you should make a note of that, because your bashrc file that you need to configure in one of the next steps, you need to provide the IP address of your VM or your host machine, and so you need to keep track of that. And that's what this note is trying to say. So assuming you were able to connect successfully to the UVA VPN, the next step is to configure your remote machine or your host machine for the ROS network configuration. And we have seen this before. Like earlier, we did something similar when we were trying to talk to the Jetson using the Pico Station wireless channel on the real F110 car. So this is sort of similar, but the thing that you need to change is you have to edit your .bashrc file in the home directory, and the edits you have to make are exactly what are shown here. You need to add the export ROS master URI and link it to the GPU serve csvirginia.edu link with the 11311 as the port. And then the next line you have to edit is your ROS IP, which is the IP address of your host machine. So this is why the previous instruction was important, because you need to be aware of whether your IP address changes from session to session. But as long as your IP address in the bashrc is consistent with your machine's or VM's IP address, you are good to go to the next step, right? So the thing in the red at the bottom, I'm not going to read out verbatim, but that's essentially what it is saying, that your UVA anywhere VPN IP4 address is required to be filled in by you. We can't do it for you. All we can provide is the GPU serve where the ROS master is hosted. All right, so we connect to the VPN and we were able to configure our bashrc file. Let me actually talk a little bit now. This is not really an instruction per se, but I'm going to just talk a little bit about what's happening on the server and how are we managing different teams. Right, so the simulator is being hosted on one of the computer science department's GPU server. Ideally, the server is always on, the simulator is always running. If for whatever reason, sometimes servers do get power cycled occasionally due to some power interruption or some network issues. If for whatever reason the simulator doesn't appear to be actively running, all you need to do is ping us on Piazza, although we are also always monitoring the status of the simulator. And it should be easy for us to instantiate the simulator again and again if it keeps crashing. But for now, we can assume the simulator is always active. And the way the simulator is configured is all the teams have all of their cars present on the same track. So on the server, we are actually just running one single simulation in Gazebo, but we have spawned 8 different cars, one for each team. And so the teams are sharing this virtual track. So you may be concerned, well, what if I crash into another car? The thing in Gazebo is that we have configured it such that although your LiDAR can detect the left and right walls of the track, which you would need for something like wall following, the footprint of other F110 cars has been reduced to a very, very small physical dimension. In the sense that even if you are directly behind another car, it would only appear like noise on your LiDAR signal. You won't. So your LiDAR is, for the most reason, intentionally blind to other cars. This is done so that each team can debug and control their virtual F110 car as if they were the only car present on the track at any given time. So I hope that makes sense. But if you face problems with that, let us know, and we'll try to clarify that as well. So the next question is, if we have a single simulator and you have 8 different cars at the same time, even with this fancy collision setting, how is it that teams actually interact with their cars? So there are 2 parts to this, remember. One part is you just need to have a package installed on your local machine, which I will talk about in the next step. And that package will allow you to remotely visualize what your car is doing, and also you will be able to subscribe to different topics and whatnot, and echo different topics as well. But in order to actually run your code in your own Catkin workspace or issue commands that will move your car in any manner, whether TeleOp or autonomous, you actually need to SSH directly into the server. And so every team has its own separate account, and we will email you the login, username and password for your team's account that you shouldn't share with other teams. So you are expected to place all your assignment codes and project code in your own workspace that nobody else has access to besides the instructors. So the GPU location is GPU serve 5 csvirginia.edu, and nothing else actually is running on this powerful GPU. It's dedicated to this course for the remainder of the semester. The only thing to keep note of, as I've said earlier, is if you are not on the UVA VPN, you will not have access to this server. So here is a better view of what I was talking about. This is what the simulation arena looks like. We can see the track is a mix of left and right turns, but at each point of the track, the car is always going to be in the vicinity of a left boundary and a right boundary, which is what you need for wall following like algorithms. And so you can say that every car has its own dedicated namespace, right? So we have 8 teams. So we have car_1 all the way to car_8, and you know your team number. So when you interact with your car, you'll only be able to change the attributes of the car with the namespace corresponding to your team name. All right, so I keep referring to this visualization package that you also need to install. This is actually pretty straightforward. All of your Ubuntu sessions, whether VM or native installations, they already have this Catkin workspace that we have been using throughout the course. Now what you need to do is you need to clone this new package called Sim Tools that was created specially for the purposes of the online simulator visualization. So we git clone this new package, we build the workspace with this new source code, and then we source our bashrc file to let it be known that the Catkin workspace devel.setup.bash is updated as well. And so once you confirm that your Catkin workspace is sourced in bashrc, you are done with this visualization package. And what this visualization package is really doing is it's installing a bunch of nodes that are running on your local machine in order to accept the data and the visualization from the server. Right, so once you have this installed, you will see this later in the live demo as well. We can open a new terminal on the virtual machine and enter this command, ROS launch sim tools, the name of the package we just installed, remote access.launch, and then you have to set several arguments when you before you hit return and launch this remote access.launch file. For every session or for every visualization, we need you to enter your UVA ID. This is the alphanumeric ID assigned to you, your UVA computing ID. That has to be added to the UVA_ID field. You need to tell us the car name, which is car_the team number that you have. And so again, this is for us to know what namespace you are interacting with. There's an argument called visualize that is set to true, which basically renders RViz and shows us the status of the car and the LiDAR laser scan. And for just visualization purposes, you can set remote TeleOp to be false. Later, I will tell you how do you actually run TeleOp using this online simulator as well. So an example is shown here. We will also look at an example when I actually run this during the demo. Right, so when you run this, so you should see an RViz window which looks something like this. The track looks slightly different. Don't worry, this is a little bit dated image because we tried different configurations in terms of the pit stops for the car. The important part is you will see your footprint of the car along with the LiDAR scans which are being visualized for the particular car which you had created you passed the namespace for in the launch command, and on the top right you will see what is called the chase cam view or the third party view, where you are not on the car itself, but you can see your car from this third party chase cam on top. So it helps in actually visualizing what your car is doing on the track. I should say here, make a remark here that although Gazebo as a simulator provides excellent visualizations on where the robot is in the environment, it is difficult to pipe all that Gazebo visualization onto the remote machine because it takes a lot of bandwidth, and it also actually poses a computation burden on the server side to send a live Gazebo visualization, because it's a 3D mesh rendering, and you can see that every frame is not really an image, but it's actually an entire state of the simulator being sent in some sense for for you to visualize it on your machine. And so you don't really need access to the real-time gazebo view of the simulator. We have found that having access to RViz and this sort of chase cam or a top view cam is more than enough to carry out all the assignments and lab sessions. Right, so I think you already know this, but just for the sake of completeness, what you see on the left panel are laser scans returned by a LiDAR. Another thing to note is that the virtual LiDAR is actually much more capable than the 4LX, which was present on the real F110 car. So this has, I think, a much longer field of view, maybe 20 to 30 meters, but you can confirm that using the echo scan packet. And this is the footprint of your car, so it's not a 3D rendering like you would see in Gazebo, but for all purposes, this is enough for you to visualize where your car is. And then you can, because this is actually RViz running on your remote machine, you can interact with the visualization, zoom in, zoom out, and everything else will also work as it does for RViz. So to recap, you are on the VPN server, your bashrc file is configured, and you have installed a remote visualization package. And using the ROS launch commands that I previously showed, and I will show you again in the demo, you can actually visualize the car. So finally, to wrap things off, let me first show you how do you accomplish teleoperation. So remember that teleop, unlike visualization, excuse me, is actually interacting with the car. So you are sending a command to move your car. So we have to make sure that you are not accidentally moving some other team's car. So one restriction is only one person can remotely control the virtual car at any given time. Okay. And the way to do that is you'd actually SSH with your team underscore number of your team. So team underscore 1, for example, at the GPU server. So you SSH. Every team has a different secure password, which will be emailed to the team. And once again, please don't share your passwords with different teams, but you can obviously share them with your teammates, who all will be copied on the email, by the way. And so you SSH into your workspace, and then the teleop commands, whether that is remote control or whether that is executing your autonomous code, they are actually launched on the server itself. So you're not launching teleop commands on your remote machine, right? So since we are SSH'd into the server, the command looks very similar to one that we had before for just visualization. The difference is, since we already have visualization running, let's say previously, in this teleop mode, we turn the visualize parameter or argument to be false. We set remote teleop to be true, and then there is another extra argument called listen off board, which is set to false. And I recall explaining what listen off board is because there's a command multiplexer which is looking at whether to run the car in autonomous mode or in manual mode. So once you have this session on the SSH with the teleop command run as shown on the previous screen, you can then use your WASD keys to remotely control the virtual race car, and you would see in the RViz view or in the chase cam view that the corresponding car has now started to move. So another thing to note is in the teleop, we have provided a special key called Q, which is for emergency braking. So if you are about to crash or there's a weird lag happening between your teleop commands and what you see on RViz, you may want to hit Q to reset, or not reset, but just stop the car. So to recap, for teleoperation, you have to use the workspace on the server to control the car. The setup tools package that you download on your VM is only for visualization, not for interaction. As always, if you have any questions, ask the instructors on Piazza, and I encourage you to publicly ask it on Piazza rather than private messages, so others can also benefit based on whether you think this question is applicable to others. I want to emphasize there is no sudo access provided to students, right? So in the future, if you want some specific package to be installed for your car, you have to let us know, and the TAs will install that package for you. And please don't try to cause intentional collisions with other teams and play nicely with other teams. One of the things I just want to say, which is not listed here, but I want to emphasize that the TAs, especially Varundev, your lead TA, has worked very, very hard in the past week, 10 days to make this possible. And the nature of our course was that we needed to meet in person and play with the actual hardware and race in person. And so to be able to do even a fraction of that online with the simulator is a big accomplishment. So all I ask is for you to be patient in case the server crashes or there's some problems. Just let us know, and we'll do our best to fix them as fast as possible. So that was all as far as the overview and the step-by-step instructions for how to interact with the simulator is concerned. But the video has not ended yet, because now I want to switch to the actual virtual machine and walk you through a live demo of everything. But before that, I need to first ensure that I am connected to the VPN. So this is the client. I'm not going to walk you through the steps for how to install and configure this. Those links are pretty good. All right, so as you can see, I'm connected to the UVA Anywhere network. And so now I can go here, and the first thing actually what I should do is check my IP address. So let's just quickly do that. Okay, so my IP address is this 2.11.55.8. It looks like it hasn't changed from the previous session when I was trying it out earlier. All right, so you can go back in the video and look at the slide deck, which will also be posted on the course webpage, needless to say. But the first step was to connect to the VPN. The second step was to configure the bash RC file on this machine. So why don't we do that? I'm going to edit the bash RC file, which is right here. And so you can say, once again, I've already added these statements at the bottom of the file and just have to uncomment them. The first line is the IP address, which was assigned to my machine using the UVA VPN. And the second is the ROS master URI, which is the address of the GPU server where the simulator is hosted. So I'm just going to save my bash RC, close, and then also source the bash RC file. Okay, so the next step was to download the Sim Tools package, which has been created by the TAs for access to the simulator. But one sanity check is you could even type ROS topic list right now, and you can see, since I changed the ROS master URI in my bash RC, I am seeing all the topics which are getting published on the server, right? So notice that I didn't run ROS core on my virtual machine, because ROS core is running remotely on the server where the Gazebo simulator is running, and you, as any team, can visualize all the topics for all the cars. But this is just visualization, so there's no harm in just visualizing the topics of other cars. But in order to interact or change any of these topics, you need SSH access. Okay, so this is a good sanity check, that before we actually run the ROS launch for visualization, just to confirm that you are on the UVA network and your IP configuration is correct, you should be able to see the list of topics if you have configured your bash RC file correctly. So this was just an additional step which was not included in the slides. All right, so our bash RC seems to be working. We are definitely on the UVA network. Now we need to go ahead and install this new package. So I'm going to change my directory to the Cutkin workspace source and then clone the new package, https://github.com linklab UVA sim tools. Okay, so that was pretty fast. Now I can just go to the root folder and run catkin make, and it should run without any troubles. Okay, there you go. And just to confirm, I can show you that in the source folder we have the sim tools, okay, right here. A good practice is to again source the bash rc, because our catkin was just updated. Let me navigate to the home directory again. Okay, so I'm done with most of the steps. Connected to the VPN network, bash rc file configured correctly, able to view the topics even before visualization, and then finally git cloning the sim tools package from linklab UVA git repository, and successfully able to make the entire workspace. So having done all that, now we can actually launch our visualization. So we can say ROS launch sim tools, and I believe the launch file is remote access.launch. There's a bunch of arguments that we need to configure. The first one is, make sure I'm not typing it incorrectly. We have UVA underscore ID colon equals, remember, not just equals. This is my UVA ID, and car name for now, let me just say car1 is what I want to view. And I'll say visualize is true, and remote TeleOp for now is false. So when we run this, what we should see, okay, what did I type? Oh, I just misspelled visualize, that was it. Okay, if I didn't make any more typos, what we should see is ROS launch, and we should be able to see all the cars running on the server. So let's just give it a second. Okay, there you go. That was pretty fast. Okay, this is not what I wanted to do, but you can see first. Okay, let me show you what's going on. So first, you can see that we can visualize the footprint of your car. So this is the location of car 1, and I can interact with the ROS window, and if I bring back the image as well, and you can play, I'm not able to find the adjustment for dragging these windows right now, but on the top right you can see we have this third party or the chase cam view of the world, where you have the car, all the cars lined up, they're always running, and so I think this is car 1, the one in yellow, and the closest to the camera. All right, so I was able to configure my ROS windows and size them properly, and this is what you should be seeing, right? So you can see it's pretty straightforward once you have the visualization installed. We cannot interact with any other car right now because remember, interaction requires the special SSH login. Right now, we are only visualizing stuff through the sim tools package. So why don't I go ahead and show you the last step of how do you actually control your car or interact with your car as well. Just make sure ROS doesn't close on me. And so to do that, we won't be just running the sim tools package on our remote machine, but we need to actually SSH as one of the teams onto the server. So since I'm using car1 as the example, I'm going to SSH as team_1 on the GPU serve 05.cs.virginia.edu And like I said, every team has a secure password. So let me just input the password for the first team. So now you see I am remotely logged into the GPU serve session of team 1, and this is where I have to launch any commands for keyboard control. This is where my Catkin workspace is also present. So let me list the contents of the directory. You can see the Catkin workspace present for team 1 is only accessible if you have the password for your respective team, right? So now that we are logged in, I can now run another launch file which will allow me to use my keyboard commands to interact with my car. So let's see whether how well that works. So this command is very similar to the command that we used to launch the simulator in the first place. So the package installed is also called SimTools, and remote access.launch. So some of the arguments are the same. I need to provide my UVA ID and my car name. Car name is car_1. This time I'm going to set visualize to false, since we are already visualizing that in the background, and remote teleop to be true. And then finally we need to specify another parameter, which is listen of board as false. Okay, hopefully there are no typos. So I can run this, and the problem is that I did not type in an equal to. Every time I type in one of these long commands with many arguments, I make one error. That's not where I want it. Yeah, it doesn't help that my terminal is also lagging. Okay, finally, once you make a mistake and correct it like I did, so now you can see the keyboard teleop and command multiplexer are running. So now if I keep my SSH teleop session as the active window, maybe let me make sure everything is visible. Oops, that's not what I wanted to do. Yeah, so as long as my teleop window is active, and probably I can keep it here. Now if I use my WASD keys, we should see the car move. Don't worry about this RViz view getting flipped. I just accidentally clicked and dragged on it because my VM is running very slowly. So you can see how I'm able to control the yellow car using my WASD commands, and if I hit Q, the car should stop. Okay, and you can correct the RViz view using your mouse. That's straightforward. But the important point is to interact with the car, I needed to SSH into this GPU directly with my team name as the username and the password, dedicated password, in order to issue any commands. Also within my, and I can now kill this node. Also within the keyboard teleop SSH session, in the same workspace, in the same session, when you SSH into the GPU serve, you also have your Catkin workspace, which is only available for your team. Okay, so that's mostly what I wanted to cover. for the simulator, and hopefully this has made it clear how to access the online simulator. The slides are available on the course webpage. Feel free to go back to the earlier part of this video to see those instructions if my typing was too fast or with typos. But it works as we have shown. All 8 teams can be logged in simultaneously, and it should be able to hold steady. If it crashes, like I said, just be patient and let us know, and we'll have it up and running as soon as possible. So this is all we need for us to attempt the wall following lab, and the next video would be the release of the assignment, where I will walk you through what needs to be done for wall following, what nodes you have to implement, and what sort of template code are we providing, along with some suggestions for how to implement it with the simulator, and what you have to actually demo for the wall following assignment. So with that, I want to end this video. Thanks for watching. Stay well, and let us know if you run into any problems. So before you go, there's one more thing that I would want to try, and that's if you freeze your car or if you crash, one important functionality is how do you reset just your car to the initial point and run everything again without sort of shutting down the entire simulator. So let me show you how that is done. So what we can say is we can set a parameter. So right now, if you go back to the example where I paused earlier, my yellow car is right here. I want to reset it to its original spawn point. So I can say ROS parameter, ROS param set, and the name of this car is car1, and there should be a reset to pit stop topic option, and I want to pass number 1 to it. And you can see when I issue this command, my car has been reset to the initial spawn point, so I can try my algorithm again. In fact, at a later stage when we release the assignment, we will also show you how you can reset your car to an arbitrary point. So if you're having trouble at one particular corner on the track, it might not be useful for you to always reset to your initial spawn point. You can spawn your reset to any sort of XY point on the track. So that will be something very similar where we set this parameter instead of reset to pit stop. There's a different parameter that we will set. But more on that when the assignment is released. And with that, I want to conclude this video of how do you access the online ROS F1tenth simulator and still be able to carry out essentially your commands for the car. Yeah, goodbye.